Good morning, students. Today we are going to be taking the course on BME 911, Applied Mathematics and Computer Logics as the title. I am Dr. Nwobudunzeribenne Harmony, the course instructor. The topic we are going to treat under this course includes Introduction to Computing. After that, we go into Boolean algebra and logic and handle some topics under it. Then we go into electronic applications to biomedical devices design. Then we treat mathematical modeling and simulation as the last topic, under which we are going to look at algebraic and transcendental equations, finite difference schemes, numerical differentiations, interpolations, and the last but not the least, Laplace transform and Fourier series. So let's go into introduction to computing. Computing is any activity that uses computers to manage, process, and communicate information. This also includes the development of both hardware and software. And we should know that computing is a critical integral component of these days modern industrial technology. There are major computing disciplines which include computer engineering, software engineering, computer science, information technology, today medicine, biomedical technology, biomedical engineering, regenerative engineering has joined the queue. So computing is basically anything that you can see that uses a computer. Furthermore, a computer is a programmed device with a group of instructions to perform specific tasks and generate results at really very high speed. So it is a machine that can solve difficult and different problems. It can process data, store and retrieve data, and perform calculations faster and accurately when compared to humans. So generally, one can say that a computer is defined as a machine which accepts inputs, processes the data it has accepted, then uses that accepted data to process instructions, and after that, finally it will give it out as an output, as a processed data. You know, the acronym computer can be said to be C for commonly, O for operated, M for machine, P particularly, U used, T training, E education, and R for research. So computer in acronym can generally be said to be commonly operated machine that particularly used for training, education, and research. There are advantages of computing, excuse me. They can help for multitasking, and that is when it allows you to do multiple tasks at the same time. They increase speed of operation. Person can save huge data when using computer, and again it can store so many amount of knowledge. Computer calculations are very accurate. Another advantage is data security. Protecting digital is understood as data security. Again, computing helps us to complete tasks that are humanly impossible to achieve in a limited time. Computer helps the user in better understanding and communication with other devices. Another advantage is on productivity. The level of productivity gets automatically doubled as the computer can do work very fast when compared to human. And having said that, you can agree with me that it reduces workload. The last but not the least advantage is reliability. Computers can perform same sort of work repeatedly without getting errors, and it cannot get fatigue like human. So disadvantages of computing include virus and hacking attacks. Virus can go to other systems from email attachments and from infected websites, and can disturb what we have in our computer. Another disadvantage could also be online cybercrime. Computing can reduce employment opportunities. Another disadvantage includes high costs. Some computers can be expensive, making it difficult for people to lay their hands in having computers. We can see it in Africa like South Africa and Nigeria, since computers help to empower people. Another big disadvantage is distractions and disruptions. Like you can have some times overspent in browsing or watching videos on YouTube, and this can distract you from doing what you are supposed to do that is reasonable with computing, like performing some official task. Another disadvantage is increase of waste, and this can impact the environment. With the speed that computers and other electronics get replaced, all of the old devices that get thrown away have a big impact on the environment. The last we are going to discuss, but not the least, could be health problems. Long use of computing can cause neck or back problem, and you can agree with me that it can also lead to eye strain. Let's now discuss binary codes. The digital data is represented and also stored and transmitted as group of binary digits, bits. This group is also called binary code. And binary code can be represented by the number and can also be represented by alphanumeric letters. They are called code. This group of symbols of bits is called code. So in coding, numbers, letters, or words are represented by the number, or the letter or word is said to be encoded. So some advantages of binary code is that they are suitable for computer applications and for digital communications. Binary codes make the analysis, designing, and implementation of digital circuits easy, since what it can utilize is only bits, only binary digits 0 and 1. So we are going to go into the second topic, which include Boolean algebra and logic, and we go through it until we get to microcomputers. Logic gates are the basic building blocks of any digital system. It is also an electronic circuit that has one or more than one input and only one output. They are named as AND gates, OR gates, NOT gates, exclusive OR gates, NAND gates, NOR gates, and so on and so forth. So the relationship between the input and output is based on a certain logic. The George Bull, in the year of 1854, introduced a systematic treatment of logic, and for this purpose he developed an algebraic system known as symbolic logic or Boolean algebra. In that note, Boolean algebra is a branch of mathematics and can be used to describe the manipulation and processing of binary information. Boolean algebra is algebra for the manipulation of objects that can take on only two values, typically 0 or 1, or typically can be true and false. So it is common to interpret the digital value of 0 as false and then digital value 1 as true. So the two-valued Boolean algebra has important application in the design of modern computing systems. So after Boolean algebra, we have Boolean expression, which combine the variables and operations to yield Boolean expression. Boolean function typically has one or more input values and yields a result, especially based on the input value, which is in the range of 0 and 1. Boolean operator can be completely described using a table that lists inputs and all possible values for these inputs and the resulting values of the operation based on the Boolean operator. A truth table shows the relationship in tabular form. That is the relationship between the input values and the result of a specific Boolean operator or function on the input variables. We have the AND operator, which is called the Boolean product, and the OR operator, which is denoted as Boolean sum. Here is the Boolean identities based on the Boolean operator. Like we have identity name, the AND form and the OR form. You can see we have the identity law, which has a Boolean product and Boolean sum and their respective outputs. So in AND is like multiplication, while in OR is like an AND. One thing you should know is that in some of the operation here, some AND form and the OR form has the same output, whereas in some cases they are different. Like when multiplying 0 with any number, the result will always be 0. And when you are in all, any high will result in a high, will result in a 1 and not the x. So when you are ORing, the high takes precedence. When you are in idempotent law, when you are doing sum of products, the x remains the product, the output. While in ORing, when you are ORing x, we are airing to the same entity, you always have the output as 1. So in this case, the AND form and the OR form under idempotent law is the same. We also have the inverse law, the commutative law, the associative law, distributive law, absorption law, De Morgan's law, and double complement law. All these are basic identities of Boolean algebra. Now let's look at De Morgan's law. So De Morgan's law provides an easy way of finding the complement of a Boolean function. For instance, let's say that we are using this x here, so, and this is not x, this is not x. So in that case, you find out that this x and this bar x, it shows that this x is completely opposite of x. Like here, you can see, like here, we have you see, we have a 0 here. Not x will give you a 1. Then we have a 0 here. Not x will give you a 1. We have a 1 here. Not x will give you what? A 0. Then here we have 1. Not x will give you also a 0. The same way, this is a y, and not y will give you opposite of y. So like we said, that in AND, AND shows product of these identities. So we have that 0 or 0 in AND will give you a 0. 0 and 1 will give you a 0. Then 1 and 0 will give you a 0. 1 and 1 will give you a 1. Then this is also, let me use yellow color to show you. So this product of sum of x and y identity has its not x and y here, showing that you have opposite of the output of this xy here. You have 0 and opposite 1, 1, and 1. So the same also is applicable for the OR expression. So in OR expression, we have not x or y, not x and not or not y. So in this case, you compare this and this. So, and in OR, we have that all high will give you high. Anywhere there is a high, you always have the output as a high. So let's move further. So in representing Boolean functions, there are an infinite number of Boolean expressions that are logically equivalent to one another. So two expressions can be represented by the same truth table, as we have seen in the other last slide. So the two most common standardization forms are the sum of products form and the product of sums form. In this case, in the sum of products form, ANDed variables are odd. Then in product of sum, odd variables are ANDed together. For instance, like we can see in this sum of products, you have all the, let me show you, all the ANDed variables, they are odd. And in this case, all the odd variables are ANDed. So that is it. Then when we are representing Boolean functions, the sum of products form is usually easier to work with and to simplify. Also, it is easy to convert a function or to sum of products form using its truth table. So in this kind of Boolean functions, we are only interested in the point where the functions are true. That is where we have a high output. So using the truth table below, we have listed the values of variables that resulted in a true function. So each group of variable is then all together, like you can see in this sum of products. Like where you have where you circle all the one, where you have a high output. So we now use all the high outputs and use sum of product to represent them, showing that wherever you have an high, you AND them. So like in this first variable, we have a not x in here. You see not x and y and z. So that is what is representing this. Then for this second AND operation is a high. You see this or this can give you a high output. We have x, we have not y, and we also have z, which gives us this output. So that is how we are able to get this sum of products for this function. So we discussed also logic gates. So Boolean functions are implemented in digital computer circuits called gates. A gate is an electronic device that produces a result based on two or more input values. In reality, gates consist of 1 to 2 transistors, but digital designers think of them as a single unit. So integrated circuits contain collections of gates suited to a particular purpose. So the three simplest gates are the AND, OR, and NOT gate. And as I explained before, this is their truth table and this is their product. This is their output. Then AND operation is denoted by this symbol like a D. You have a OR operation in this shape, and we have inverter also in this shape. Then another very useful gate is the exclusive OR. So in the exclusive OR, the output of operation is always true when there is a difference in the input. So anytime there is a difference in the input, it gives you a high. But when the inputs are the same, you always get a 0. That is an exclusive OR gate. Then we have the NAND gate and the NOR gate, as I mentioned before. The NAND gate is opposite of AND gate, while the NOR gate is opposite of NOR gate. Then we have the universal gates, and the universal gates are mainly NAND and NOR gates. This is because they are inexpensive to manufacture, and any Boolean function can be constructed using NAND gate only excuse me, or NOR gate only. So the three circuits constructed in this slide is using only NAND gates. Then we have the multiple input gates, which can have multiple inputs but one output. So every computer is built using collection of gates that are connected by wires acting as signal gateway. So let's look into some digital circuits and their relationship to Boolean algebra. Like from the slide, you can see that more complex Boolean expression can be represented as combinations of AND, OR, and NOT gate, as you can see in this diagram. So when they are represented, in many forms in a circuit, the logic circuits can be said to be combinational logic or sequential logic. So the key concept in recognizing a combinational circuit is that an output is always based on the given input. So in combinational circuits, the output is always based on the given input. The major weakness of this combinational circuit is that there is no concept of storage. They are memoryless. But when we change an input value and the input value has direct and immediate impact on the value of the output, then you can say that it is a combinational circuit. Then a sequential circuit defines an output as a function of both its current inputs and its previous inputs. Therefore, the output depends on past inputs. In this case, a storage element known as flip-flop is involved. So combinational circuits are generalization of gates, while sequential circuits are generalization of flip-flops. We have integrated circuits. These integrated circuits are a combination of gates combined together. So gates are not sold individually. They are sold in units called integrated circuits. So a chip is known as a small electronic device that consists of electronic components, which include transistors, resistors, and capacitors, and all are used to implement various gates. So a chip is a small silicon semiconductor crystal. The first IC that was produced was called small scale integration chips, and it contains up to 100 electronic components per chip. Now we have ULSI, and this ULSI, ultra light scale integration, has more than 1 million electronic components per chip. So the diagram we have here is a small scale integrated circuit, the simple one, and you can see here that it is made up of 4 NAND gates. So after the SSI, we have the LSI, large scale integration. We have the MSI, medium scale integration. Today, ultra large scale integration is available. Excuse me. So in the slide, we have the Boolean circuit of an inverter and an AND gate. So in this inverter, it shows that any input here should be inverted before the AND operation takes place. They can be rendered using NAND gates, which means you can still use this, convert this inverter to be a NAND gate, and that is what is implemented here. So we can wire the prepackaged circuit to implement our function. So actually you can replace an inverter with a NAND gate and use it to form your integrated circuit. So from let's go into using a problem to describe an IC which can be implemented in a circuit. So Boolean logic is used to solve practical problems. So they are expressed in terms of Boolean logic practical problems, and can be expressed first of all by truth tables. So truth tables is an easy way which can render and explain Boolean logic circuits. Suppose we are to design a logic circuit to determine the best time to plant a garden. We will consider only three factors, which are the inputs. One, we consider the time, we consider the moon phase, and we consider the temperature. So let's say that 0 will represent day and 1 represent evening. Then the moon represents 0 when the moon is not full, and when 1 represents when it is full. Temperature represents, 0 represents 45 degrees Fahrenheit and below, while 1 represents over 45 degrees Fahrenheit. So let's determine the best time to plant a garden, whether it's during evening with a full moon. So we are going to determine that the best time to plant a garden is in the evening when there is a full moon. So what that means is that anywhere we see a high for the moon and we see a high for the temperature, that means it is the best time to plant our garden. So this is the result of the truth table. So we are saying that any time that the moon is full and the temperature is also above 45 degrees, that is when is the best time to plant, and the time must also be at a high, because we are looking at the best time to plant. So which means at 00 digit, that is not the best time to plant. At high level 111, it is the best time to plant. But another factor to consider for the best time to plant is when there is a full moon and when time is above 45 degrees Fahrenheit. So let's consider it. Here we have the time to be high. The moon is also full here. So this is the best time to plant. Then we also have the time here. The moon is full here and the temperature is also high, which means this is the best time to plant. So we said that it is when the temperature is below 45 degrees Fahrenheit, it is not the best time to plant. So having see this high as the output, so we now use it to to derive our algebra. which we now use to get this circuit. So in this expression, we will now have in a high, we have a high x, the best time, and the moon is also full, and the temperature is not disturbing. So that is the best time to plant. Then we also have when the moon is full and temperature is full, which is also the best time to plant. So when we do combinatorial combination, you find out that this not z and not x will give you a 1. Not z and not z will give you a 1, which means we will now have x and y as our output. So this is the circuit we will use to implement this operation. So let's also go into operational amplifiers, analog computers, digital to analog converters. So an operational amplifier, as shown in this diagram, is an integrated circuit that can be used to amplify weak electrical signals. So operational amplifiers has two inputs, as we can see here, the non-inverting input and the inverting input. So its basic role is to amplify and output the voltage difference between the two input pins. So an operational amplifier is not used alone, but is designed to be connected to other circuits to perform a great variety of operations. So when an operational amplifier is combined with an application circuit, it helps to amplify weak signals to strong signals. So operational amplifiers behave similar like a megaphone, where the input signals is a person's voice and the megaphone is the operational amplifier circuit. So for example, such circuit can be used to amplify minute sensor signals, and these are the things operational amplifiers can do. So you can see a circuit without amplification, so there is no operational amplifier here, but here we have amplified signal using an operational amplifier. So the sensor picks up the signal, the op amp amplifies it for the controller to be able to use it. Then a professional amplifier helps to eliminate noise from an input signal. Like here, there is no operational amplifier to remove the signal noise, the noise from the signal. But here, with the input of with the use of operational amplifier, noise can be filtered for the microcontroller to make use of it. Then there are types of operational amplifiers. We have the inverting amplifier circuit. That is, inverting amplifier circuit is indicated by a minus sign. So the voltage in increases while the voltage out decreases. Then for the non-inverting amplifier, it also helps to amplify an outputting signal. So the voltage out is 1 over R2 over R1 times then by V in. We also have a voltage follower circuit. Voltage follower circuit is a non-inverting amplifier circuit where R2 is short circuited and R1 is open. So V out is given as 1 plus R2 over R1 times V in. So a voltage follower is used as a buffer circuit to convert the impedance or to separate circuit. Then you have the differential amplifier circuit. So they are used for amplifying and outputting the difference between two input signals. So an analog computer is used to process analog data and work on an analog signal. It is a computer which uses continuously changeable entities like mechanical, electrical, hydraulic, and so on. And they do not use discrete values, but use continuous values. They store data in a continuous form of physical quantities and perform calculation with the help of measures. They are mechanical, electrical, or electronic computers that perform arithmetical operations by using some variable physical quantities such as mechanical movement or voltage to represent numbers. They are excellent for situations which require data to be measured directly without converting them to numerals or codes. Analog computers are used in industrial and scientific applications like control systems and aircraft, and they have been largely replaced by digital computers due to the wide range of complexities involved. So it is quite different from digital computer because digital computer makes use of symbolic numbers to represent results. So let's go to digital to analog converter, which is DAC. Digital to analog converter is an electronic circuit that converts any digital signal into an analog signal. So the digital signal are known as the binary digits, and they are made up of the highs and the lows voltage levels. So the work of the DAC is to convert these digital signals into analog signals. They have digital inputs and single analog input. Why must we convert? Because the information that exists in real world is in analog form. They have to be converted to digital form, and after it will be converted back to analog form. This is because the processing speed of a digital computer is very fast and can compute or process any data in a matter of microseconds. Then it conserves time and helps in processing complex data according to our needs. But we cannot understand the digital data in real world. So for us to understand the data, we have to process in a digital domain, and we need to convert it into analog domain to be able to also use it. So an example will be the process of audio and video editing. When we capture the data using a digital camera and microphone, it is converted to analog signal and again into digital signal. So we process it using our computers to edit it according to our needs. And in order to view our edited work, we use the digital analog converters to convert it back into the analog domain to view and listen to it through our screen and our speakers. So as represented here, the digital binary digits will always exist in bits. Like we keep saying, the bits are in one or zeros, and they can represent a weight of corresponding to each position. So the weight is always in 2 raised to power n, where n can be position of the bit from right hand side as it starts from 0. So the weight is 2 raised to power n. So bit weight of 4 bits from left 2n, you can see 2 raised to power 3 is 8. So you have 2, 4, 6, 8, and so on and so forth. So now adding the weights of all the bits with is binary in a binary number. So this is how to convert the binary number to get the actual figure of what this binary digit is in real world. So we have the application of a digital to analog converter. We can use it in audio, in converting of the audio signal into analog nature, and after it will be converted back. We can use it in video. A digital video player has digital video ports such as the DVI or HDMI. So it can also be converted to digital to analog signal. We can also see it in motor control. We can also see it in motor control. So let's go to signal analysis. Signal analysis involves the ability to collect and understand sensitive information that is sent via various signals. So signal processing is nothing but an electrical engineering software that focuses on analyzing, modifying, and synthesizing signals such as sounds, images, and scientific measurements. The techniques involved are used to optimize transmissions, digital storage efficiency, correcting distorted signals, subjective video quality, and to also detect or pinpoint components of interest in a measured signal. So biomedical signal analysis allows us to extract meaningful information from biological processes, thus enabling the assessment, characterization, and understanding of their originating mechanism. So biomedical signals, however, are non-stationary and have statistics that change over time. As a result, conventional frequency domain signals analysis have their limitations, and a more powerful analysis technique is needed, particularly one capable of characterizing the changes in spectral content over time. So this is an example of signal analysis. You can see here audio signal is being changed into electronic signal by a transducer. Then we have the electronic processing. After the processing, is being transferred through the transmitter. Then from the transmitter, which the electromagnetic wave is taken to the receiver, which receives it, and the electronic signal is also converted back to audio signal by the means of transducer. This transducer can be DAC, the analog to digital converter, and digital to analog converter. And there you can see the analog signal is being perceived by the human ear. Human ear cannot listen, cannot hear or perceive the digital bits, the digital signal. These are meant for only the computers, the bits. So the analog signal is what we can perceive in this signal analysis. So let's briefly look at computer-aided design and techniques. Computer-aided design is the use of computer systems to assist us in the creation, modification, analysis, or optimization of a design. It is the use of computer systems to assist in the creation, modification, analysis, and optimization of a design. So the CAD software is used to increase the productivity of the designer, improve the quality of design, improve communication through documentation, and to create a database for manufacturing. So the output is often in the form of electronic files for printing, for machining, or other manufacturing operation. So the CAD is used in many fields. It is used in electronic design, known as electronic design automation, or EDA. In mechanical design, they are called mechanical design automation, or MDA, and it is also known as computer aided drafting, which describe the process of creating a technical drawing with the use of computer software. So current computer aided design software packages ranges from 2D vector-based drafting system to 3D solid and surface modelers. So modern CAD packages can be frequently allow rotation in 3 dimensions, allowing viewing of a design object from any desired angle, even from the inside looking out. So some CAD software is capable of dynamic mathematical modeling, in which case it is marked as CADD. CAD is used in design of tools and machinery, in the drafting and design of all typical types of buildings, from residential types to largest commercial and industrial structures. Like we have the AutoCAD. Then it can be used for detailed engineering drawing, like the 3D models or 2D drawing of physical components. But it is also used throughout the engineering process, from conceptual design and layout of products through strength and dynamic analysis of assemblies to definition of manufacturing methods of components. It can also be used to design objects. They can be used for application that now offer advanced rendering and animation capabilities, and this helps engineers to better visualize their product design. The 4D building information modeling is a type of virtual construction engineering simulation that incorporates time or schedule related information for project management. So this is a typical product lifestyle of a computer aided design. So this is the design process synthesis. You start the design needs, you design, you have your definition, the specifications, and all that you want to get integrated in your design. Then you collect, relevant design information and feasibility studies, and from there you move into design conceptualization and design modeling and simulation. So all this design process stage is called the synthesis. Then the CAD process starts from when you are doing design analysis, design optimization, design evaluation, and design documentation and analysis. So the manufacturing process now starts from when you process your plan. Under that, you have production planning, design and procurement of new tools, other materials. Then you use your NC, CNC, DNC, programming to do your production. So that is in the CAM process, in the manufacturing, computer aided manufacturing process. So you now use the software to do your production, the quality control, the packaging, the shipping, and all these, is what you now use after the product is produced. Then you market. What I have explained, the diagram is diagrammatically shown here. You see, from computer aided, you go to rapid prototyping. These are the link of how you can use your computer aided designs. The applications are CAD, CAM, and CAR, and KEE. So KEE deals with engineering, CAM is used in manufacturing, CAD is used in design and defines geometry. So all these are the links on how computer Phd design can be used to get rapid prototyping. So we now go to the final topic on this second topic, which is microcomputers. So microcomputer is an electronic device with a microprocessor as its central processing unit. Microcomputer was used before for personal computers and any class of small digital computers that has central processing unit contain a single integrated semiconductor chip. So computers vary from desktop computer, laptop, smartphone, notebook, tablet. Then for microcomputer is also used in healthcare industries, and this goes from maintaining patient records to analyzing data to documenting time of professional efforts. So microcomputer provides specific benefits to today's healthcare professional. Recent advances in microcomputer technologies has made a new generation of personal computers feasible and affordable. So looking at the use of microcomputer in medicine, we can see it in medical and patient data. When examining patients, doctors and nurses can take notes and prescribe treatments at the point of care, because all your records are documented in a computer. It can be used in medical imaging and equipment. It can be used for patient monitoring like in your phone. In medicine, computers can be used for research. It can also be used for communication and telemedicine, and it can also be used for taking medical inventory. So these are electronic applications to biomedical devices and design. So medical electronic devices we know include pacemakers, defibrillators, drug releasing pumps, hearing aids, and diagnostic equipment for measuring, monitoring, and recording body functions such as heartbeat and brainwaves. It can also be applied for development of new sensing technologies, biomaterials, microelectronic devices, microfluidic systems, and microelectromechanical systems, and so on. And this opens the window to new biomedical circuits and system opportunities. This will help to measure better and to develop alternative methods to find relevant information for physicians and biologists in application such as diagnosis, therapy, clinical tests, and biosignal monitoring. So we can also see that medical devices can be developed using this process. After your ideation, you go and develop, validate, design, bench test. You also redesign when there's error. All these involve during invention and prototyping, which also involve the pre-clinical testing. Then after the pre-clinical testing stage, you now study, collect data, analyze data, and in case there is any form of improvement, during clinical stage, that can be done. Then when the finally satisfied as being okay, then it can be taken to regulatory decision point where assessment is based on pre-market submission. Then when it is certified, there will be product launch. Then this product launch will now lead to post-market monitoring to see the view of customers over the product that is being developed. That's new medical device that is being developed. And when developing new medical devices, we looked at 5 major points. One, there must be the feature of early detection of health problems. There must be non-invasive diagnostic option. It must be easy to operate, and it can also be safe for home use. And most importantly, it must be safe for both the patient and the healthcare providers. Computers can be used for telemedicine, as we can see in the slide. It can be used for 3D printing. It can be used for telecare. It can be used for big data analysis. It can be used for point of care test. And that is where we are going to stop our lecture for today. So in the slide here is an assignment for today, which you are going to do. So you are going to design a baby incubator that gives an alarm when the time exceeds 30 minutes, when the door is opened before 30 minutes, and when the power button gets off. In this, show the truth table, the Boolean algebra, and the logic diagram. And number 2 assignments is, what are the factors you need to consider when using an operational amplifiers in the design of medical devices. Then the last but not the least in the assignment is for you to write on different types of operational amplifier. So with this, we have come to the end of the first lecture, and I say bye for now. Thank you.